Hello, 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 and welcome back to yet again another Free Support Friday. As you guys know, I am Fusion Phil over here at jitcadcam. We're going to give this a few more minutes before we kick it off. I do see Travis out there in chat. Travis, great to see you as always. Go ahead and let me know if you can see and hear me all right so that I don't butcher this right off the start as always. Hopefully Travis had a pretty good week. I think Travis, were you here last week, by the way? Awesome. Sounds like, or per the chat, we sound and look good. Yeah, in and out. Hey, Deep Thinker, there we go. Sound and video check is good. Great to hear it. Hopefully you guys got a bunch of interesting stuff for me this week, because I have a few things to kick things off with. For those of you that do positional machining, I think you're going to like this a lot. Cool. Let's go ahead and jump over. I'm going to share my screen, and let's dive into a couple of things. So I'm going to go ahead and start with a question that I just got probably 30 minutes ago, and it was very interesting nonetheless. So what you're going to be able to see here in a sec, I'm getting a 3+2 part opened up for you guys to see. But the question was around when you're doing tool pathing on a part like this, is you're going to have to come in and you're going to have to do things at certain angles. And as you can see here, I have my toolpath programmed up here. And for most of you, you're very familiar with tool orientation, right? So the problem with tool orientation is if you're jumping from 2D to 3D toolpaths, things like that, you lose the workflow of being able to derive out of one toolpath into a 3D toolpath or from a 3D back to a 2D, right? So if I wanted to, and I'm going to go ahead and clean this up here real quick. I think you guys will appreciate it a little bit more, but let's say I was going to do a traditional approach here, right? I'm using 2D adaptive clearing. I want to do tool orientation to this face. And then as you guys are pretty familiar, we pick our chain, right? So what you're noticing is I'm coming in at that angle to machine out that pocket. But now, because I roughed out that pocket, maybe I want to finish the floors. Well, again, I would go back, do my 2D actually not 2D, I apologize. We're going to go for horizontal. And this time I'm going to make it a little more of a pain. We're going to go ahead and say Z this way, maybe X this way. I do need to flip my X axis. And what you're noticing is the amount of clicks I'm starting to do here. So again, we're going to go ahead and give this a boundary real quick. Pull inside that area, nothing extra. And as you're going to see, we're now finishing that floor, right? But when it comes to that tool orientation, some things you guys noticed is the amount of times I had to do different mouse clicks for orientating my axes. Now, that would be a pain if I had to do this across a couple of tool paths. But did you know, you guys will have to tell me in chat, you know that you could actually use joint origins to control your tool orientation? So as you're going to see me do here, I'm going to jump back to design. Now, keep in mind, in a jig and fixture buildup, as you guys are seeing here, your part will have to be its very own component in order for this to work. But if I wanted to go ahead and square things up to this pocket, and again, I'm going to use this bottom edge, right? I'm going to go in and I'm going to do a joint origin, and I'm going to place it on this face where I can hold control and snap to where I want it. And then in this case, I'm going to go ahead and spin it 180 degrees. Now, based on that color coding inside of Fusion, again, we know red is X, blue is Z. And as you're seeing, I'm now setting this joint origin so that it's square to those faces, right? So when it comes to tool pathing now, this is going to be the cool thing, right? We're going to go ahead and delete these tool paths. But if I went in, again, traditional approach, 2D adaptive clearing on this pocket, I go back to tool orientation, there's an option here to pick a coordinate system. Now, I can pick that joint origin. As you can see, my X and Z are automatically orientated to that joint origin. So again, we go back. I do now maybe 3D. We do horizontal. Again, tool orientation. I want to pick what I want to use. So again, I'm going to say coordinate system. And again, that XYZ is now orientated once again. Now, again, tons of value here. Obviously, we're going to throw a few more things at this, as you guys saw me do the first time through. Tool inside boundary. Anybody out there doing fourth axis work, you could see how much better this could make your life when setting this up. Now, a few things to keep in mind. Well, hold on. We're going to go ahead. So any feature you can use tool orientation, go ahead and place origins ahead of machining. Yeah, I mean, 100%, Travis. That's one big thing about it is the ability to set up that joint origin so that it works for you. Now, on the basis of my setup, now keep this in mind, guys. I think a lot of you saw where that doing that tool orientation, if I didn't use the joint origin, again, I'm going to do this again real quick. Your post processor is actually going to handle what happens when we use that joint origin, right? So again, is right now you're seeing we're pulling everything from our setup origin versus you saw that actual XYZ system move over to the joint origin. For those of you that are using something like Siemens, Fanuc, things of that nature, let me go ahead and give this a chain. What's going to happen is when you're using 68.2, it's actually going to shift you out to where this joint origin is. So a good example of why this is valuable is in the event I wanted to go ahead and define my cross holes here, right? If I did the same process all over again, we're going to go ahead and make a joint origin here. Again, you're going to set it which way you want it. So we're going to flip mine back the other way. But the G code itself will actually have that 68.2 shift. And then you can use that 68.2 shift, of course. Again, we're going to go in, coordinate system. As you can see, I've set it to center. That would be where my hole is. Again, when we post this out on something like a Fanuc post or a Siemens post, we go ahead with this DN Solutions post. And we got to make sure that we do have 68.2 turned on. Is it is going to provide the shift in X, Y, and Z. So what actually is happening here, oh, we're looking at the wrong thing. I apologize. So we have our tilted planes happening, but there is no X, Y, and Z shift. We can force an X, Y, and Z shift if you want to see where that exact location is, or if you're machining something from datums, of course. But as you're seeing, where that actual origin is sitting when we use a joint origin doesn't really matter, because this is all still coming from that center work offset on our part where we set this up. And the same thing would be for you Haas guys and anybody else out there. So if you're somebody doing quite a bit of work in that mindset of fourth axis machining, right? Let's say, for example, this is sitting over to the right of our table. Again, we could actually place 2 or 3 joint origins to get to certain angles that we're going to consistently use on that part. So you guys let me know in chat. Did you guys know that you could use joint origins for that? It was something that one of my customers asked me if there was a way to always set a reference for tool orientation, so I didn't have to go through and select it a million times. But as you can see, it actually helps out a ton if you're going to be doing it more than once, of course. So outside of that, another really good question that I got today was, I'm going to go ahead and let's give this a machine. Believe I should still have a UMC 750 sitting around here, or a VMX 30, I believe. I'm going to go ahead and download and save this model. I apologize, guys. I don't memorize every machine out there possible. So we're going to go ahead and see what happens when we bring in this VMX. So it will take a couple of minutes for downloading it. Hopefully this is a full 5-axis machine. So those of you out there running a Herco machine, you would be able to tell me right away. We lucked out because it is 100% a 5-axis machine. Now, if you haven't seen, again, another pro tip here is you can use joint origins as well in design for your fixture point. So again, is if I wanted to set a known fixture offset or a location to connect my fixture to my table, these joint origins, again, can be very valuable on parts like this. So let me go ahead and back that up real quick, because I am breaking the cardinal rule, as you guys know, is turn on design history. Always make sure your design history is turned on. But let's just say, for example, here is I'm going to do a joint origin, and I actually need to comp my part a little bit, maybe to the left, maybe up a little, maybe even a little deeper, right? So that joint origin is now in a completely different location, but I can use that joint origin when setting up my fixtures in my manufacturing, right? So as you guys may know, you have your fixtures here, of course. I could actually say my fixture attachment point is that joint origin, which means when we jump over to where we place our part, we have that actual ability to use that as well. So again, let me get zoomed out here. I apologize because I did not build this machine sim, so it probably looks a little wild. This was one pulled from the default library. Again, we have our fixture attachment point. We have our table attachment point. so forth and so on, right? So there we go. If you guys didn't know, the secret to all of this is to not put your part in completely sideways like yours truly did. So let's go back here. We got our Z up. We have our part on our table on our machine. And I'm more than certain this machine is probably butchered because somebody, aka me, had to do something weird here to get something done, and I broke that machine. So again, we have our tool paths. We have all of our settings here. We can go ahead and post-process, or we can simulate with machine. Guess the good question would be is let's make sure that this works the way it's supposed to, right? So again, I don't know who built this machine. We're going to go ahead and turn the base off so we can see. So as you guys can see, my part does come through automatically the right way. It is now sitting on the table, of course, and we're machining this off, right? So another question I got today was a lovely text message with a photo, but the problem was with the customer's tools. So what I'm going to do is they imported a specific tool with a holder. Actually, they imported a holder. And what they had was an issue with the gauge line. I'm going to show this to you guys. I have to access my tool library in a little different way. So let's go ahead and grab a specific tool. So this was one that was very interesting to me because their holder geometry actually required the whole cap 40 at the top. What I'm going to do is I'm going to add one more layer here. And that layer at the end of the day might actually need to be moved up. But let's just say it is 1 inch. And we're going to go, let's go 1 inch to 1.5, right? So you're noticing this down at the bottom. And there's these check boxes now for above gauge line versus below gauge line, right? So this is something that where your gauge line sits is what is going to affect how your actual tool interacts with your machine, right? But as you guys can see, is I can turn off this gauge line all the way up, and you can set a specific known location for that to happen. Now, something that's a little ugly here is you're noticing when I add in a segment, it always wants to drop it in right below wherever it is that I set it, right? So again, as I'm trying to force something to happen here real quick, let's go 3. All right, that's looking a little better. Upper diameter like 0.75. And as you guys can see, I now have that upper taper in my part. I'm going to go ahead and delete this other one down at the bottom. So where that gauge line is when you're using or building a custom tool holder, or a custom holder for milling at least, that is where it's going to place it in the machine, right? So let's go ahead and copy this holder over. I'm going to place this back in the file that we're working on. And we're going to place that holder because I need to now edit my tool to force this so you guys can see this, right? So we're going to go to that holder. We're going to go ahead and select our holder right here. As you can now see, we have this massive holder. Yes, guys, I know it's like a cat or like a, what is it? A EP13, and you got a shell mill in it. I get it, guys. But when they simulated this, this was the important thing. So they went ahead and simulated this part. And again, we're going to give this a minute to think about what it wants to do. And as you would see, do you notice how my tool is hanging all the way out, right? So even though that model had that cap 40 set on it, my gauge line is still at the top of that model. So you got to be careful about that when you guys are setting things up and editing these tools. Again, I'm actually going to have to go into that physical holder, and I'm going to make sure that that holder, I have my gauge line set appropriately, right? So again, they now have this lovely checkbox to move your gauge line. And you also have a gauge length for any of you guys out there that actually use gauge length on your machine. I have videos on it where you're using presetters. But upon moving that gauge length, we should, this is a hard should, be able to fix what is going on inside of machine simulation. So as I see you guys coming and going, I see a bunch of people. Feel free to jump in with any questions at any time. I am going to go ahead and edit this tool and verify that it moved and that I don't need to select that holder again. It does look like I do. So again, I reselected the holder at my tool level. And now let's hit this with machine simulation. And of course, we're going to use the S key for the shortcut menu because yours truly forgets that it's there. Any other questions about that? So as you guys can see, being able to go in and utilize gauge length or the gauge line and still have that modeled tool holder if you're downloading something from somebody out there, a vendor of some sort, but being able to fix that. So I did get some questions from somebody else. I don't see Matt in the chat today. He messaged me about doing some tool break control type stuff. So I'm going to go ahead and investigate that while I wait for you guys to put some more questions in chat. So in the case, he actually utilizes a Akuma machine. So I am going to go ahead and pull an Akuma post. And what we're going to do is we're going to hit post process. We're going to go out to our library, of course. A lot of these post processes are in here are completely butchered at this point, if you guys didn't know. So let's find Akuma. Actually, we could just search it over here. And there's our Akuma milling. So we're going to go ahead and select. We're going to put it in our free support Friday. And the thing is a lot of posts, it's kind of funny. So I get these questions all the time about some posts have certain things, other posts don't have things, which is kind of funny. So again, on the Akuma, they're running a Renishaw probing system, which means they do have a presetter in the machine and they have the ability to do break control. But as you're seeing, there's no options here to actually go in and set that up. So the first thing I always tell people to do on something like this is we want to go ahead and see if there is break control in this post, right? And what break control is the ability to go in and check the tool when you're done using it to see if it is broken or if it's out of spec, right? So at a quick glance, I'm not seeing anything under break and I'm not seeing anything under control. So if I was somebody that wanted to edit my own post or take an attempt at it, is I tend to look for a post that would have it. Now we do luck out here. I believe the DN Solutions post does have it. I'm going to go ahead and close this out. So as you can see, we have tool breakage tolerance. And that would tell me right away that the USA or DN Solution post, I'm going to get in trouble one of these days for mixing those two up. But we're going to go ahead and look at breakage tolerance. So we do have tool breakage tolerance here. That will be triggered by something along the way. But as you can see, is we have a case here, command break control. So if Matt Van Loo was out there, Matt, you're probably going to watch this later today because you're probably busy with something else. We could very easily copy and paste this into our other post, allowing us to have the option to turn this on. Now, you would need both sections of this for most people. So we would have to copy all of this as well. We would need to copy in our tolerancing and paste that over in our other post in the right area. So I do see some other questions coming in here. In the mill, you use a boring bar as and end mill so I can cut an undercut, but it wouldn't let me profile a radius. Travis, can you send me a part so we can take a look at that? And let me go ahead and see here. So I see something else, a Harvey tool. Let's see what we have. Let's go ahead and I need to throw this out there and search what this tool looks like. Oh, so that's just a thread mill. That's all that is. So let me get back here real quick. And let me just double verify something. Okay. And what I'm going to do is I'm going to go ahead and jump in and see. So 100%, Travis, you are correct. I don't know if that tool is in there, but so you guys know, you can download tool catalogs. I'm going to go to my tool library. And then down in this bottom left-hand corner, you have download vendor libraries. That is going to take you to Autodesk's website where you can look to see if you can find that tool specifically. Now, as you can see, there's Harvey Tool Specialty Tools, Harvey Tool Hole Making and Threading. I'm going to go ahead and hit for Fusion, which as you can see has now downloaded that JSON file. And what I need to do is I need to import that file. So what I'm going to do is go to wherever you want it, whether it be cloud, highly recommended cloud, guys. I'm going to put it in my shop crib area. So we're going to import library, Harvey Hole Making. This will take a second because it is a giant CSV file. Now I've imported that entire catalog and let's clear our filters out. So if I was to search that EPDI number, we may come up with what we're looking for. Let's go ahead and search again. What I'm seeing, though, in this particular tool, I do not see that specific tool. So it may be something that we will have to model. So give us a quick second here. That would be, oh man, my brain is not working today. That isn't hole making. That's going to be milling, and we are looking for thread mill. So it looks like no thread mills actually came through, even though that said threading on the catalog. So as you're going to see, we could go ahead and build one from scratch, right? So I'm just going to put this right inside with everything else I've done. I'm going to go ahead and hit the plus. I would like to build out a thread mill. And now I'm saying thread mill in this case because this is calling out as a double angle shank cutter. Now, it will be easy to give the cutter diameter 0.93. Let's go ahead and run through here. There's a couple other ways I'm going to show you guys how to do this as well. Cutter width 0.46. Shaft diameter on this. Neck diameter 0.47. Overall length won't really matter for what we're doing. Neck length 250. And then we have a flute length. I think it said, where was it here? 0.46. As you can see, you can fill this out in any fashion that you want. Now, again, I'm going to go ahead and plug in that 0.46 a second time. And then we're going to call this out as a 90 degree or a 45 degrees. So again, probably don't need a 2-inch length on this. So let's shrink it down to 1 inch. But as you guys can see, I've now built that profile for milling, right? The one thing I might need to do otherwise is I assume you're using this tool for what I would call either chamfering or backhole chamfering. If I'm correct, go ahead and let me know down below. Hey, he's here now. Matt, you're going to have to rewind and see where I was talking about copying and paste across the post your tool break. But as you can see, I just went ahead and modeled that as a threading tool. Now, again, based on whatever he was trying to use it for. So if I go ahead and say 2D contour, we're going to go ahead and set our tool orientation like you guys saw me steal before. I'm going to go ahead and just use coordinate system off that joint origin. And I could go ahead and pick that tool. So not the perfect use case here on this part in particular. But as you can see is I can define those edges. I have my lead in and lead outs, which will probably cause me a problem. And as you're seeing, you're going to get something like this as a warning, right? Text it. I can't share the model. Okay. So as you're seeing is I tried to cheat the system and use that as a threading tool, but now I can't use it for a contour, right? So if you were looking how to model a single point threading tool, you saw it there in real time, but let's go back and look at our tool library for something else that might work. So again, I'm just going to keep plugging this right into this library. For those of you at home, you may want to put it in your machine library or your shop crib, right? So let's do this one in the shop crib, and I'm going to stick it on our VF2. So again, I'm going to hit the plus. This time I can look at possibly instead of using that one in particularly, I have, where is it here? There is a chamfer mill that I can't ever seem to see. Where do they hide it? One of you guys are going to let me know in chat before I find it. You always do. So we have a engrave / chamfer mill. And the same rules kind of apply, right? So I have to move my menus around. So if anybody says anything in chat, I'm not going to see you here for a couple of minutes. But again, we have our cutter diameter 0.935. And then we have our shaft diameter. That was neck diameter 0.47. And as you can see, I have now modeled this out again. I'm not going to run through all of these. I think you guys are starting to get it. You know, you got your flute length, yada, 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 yada. This time, though, I did it as an engrave / chamfer mill, right? So the cool thing is, go ahead and hit accept. Again, we need to go back to that tool path that I butchered or create a new one. So we're going to go with the 2D contour. I'm going to go to that VF2 where I made that tool. There's my engraving mill. And then from there, of course, tool orientation. I'm going to pop that off right on the coordinate system so that I can just use a simple point here. And then our geometry. And because that is a chamfer mill, we could set our chamfer width, whatever he wanted to do at the end of the day, right? And as you can see now, we have a tool path. Granted, this tool is microscopic, as you can see, so it won't be massive at the end of the day, but we're still getting to where we need to be. So I hope that helps. Let me get back to my chat, guys. So Chuck, I hope that helps you out. As for Travis, texted it to me. Let's see what we were talking about here. Ah, okay. So you have an O-ring groove in there. And then let me scroll up to your question. So your question was, used a boring bar as an end mill so that I can cut an undercut, but it wouldn't let me profile a radius. Okay. So did you model that or try to use that as a T-slot cutter? Because I assume you're saying you put a boring bar in your machine and spun it like an end mill, correct? Awesome. Looks like we helped Chuck out. Thanks, Chuck. I appreciate the questions as always. If anybody else out there has any questions, guys, I live in North Dakota. It's kind of a blizzard outside, except it's not snowing. It's just blowing snow everywhere. So I didn't get a chance to go get a drink this week, so I'm just drinking coffee. Travis, maybe I should just call you and put you on speakerphone. So I'm going to go ahead and model up what he kind of sent me real quick. So he has a part. And then he has a internal, I think off the top of my head, he had something like this. He had something about like so. Actually, that could have went all the way up. It's not a big deal. And then he had what would look like an O-ring groove, right? So let's go ahead and drag this up. Now let's get some dimensions going. Little secret for you guys, I did a video on this. You now make a center line here, boom. And all my dimensions are radial. As long as I click that center line, right? So again, we don't want a 12-inch diameter part, but we're going to leave that before it breaks everything. Okay, the bottom is a 0.75. Our next step up is going to be, you know, like 0.75. And then our O-ring is probably going to be something like 100. And that diameter of the O-ring, but plug that in. We went, what, 275? Let's go 125. Almost looks like a part, right, guys? Height, 0.5. Overall height, go ahead and go with like 3. Of course, we need to place our O-ring groove. Go ahead and this 0.5 from the top, right? Yeah, you don't want to embarrass everybody with that Southern Cajun accent, huh? So I'm modeling up what you got anyways, Travis, so it'll be all right here. So let me bring this in. This is where we're going to change our 12 to like a 5. We could probably go 4, right? So Travis's part, I have to work some magic here in a second. He also has a lovely little fillet down here. And then let's do, again, pro tip here, guys. You could do a section analysis, but do you want to see something that I complain about, but I understand is when I say section analysis on the design side of the software, right? When I switch over to CAM here, if I can ever orientate my model, right? Travis, let me know in chat. That's what you're talking about. You cut this actual O-ring groove, and then you were talking about wanting to blend down here at the bottom, right? I did my section analysis in design, but when I jump back to manufacture, I don't have an option to use that analyze, right? So as you're seeing, I have to recreate that section view on my part. But here's one that was a super cool trick to help people out, is when I create my section analysis, if you're like me, I'm getting lucky because I'm able to move my mouse, but as you can see right now, I can't pick that plane, right? So it's trying to grab the surface, and if I left click and hold, it will actually try to select anything where your mouse is projecting through. So as you can see, through my part, I can actually grab that face. So, Travis, we're still waiting for you. I assume you were talking about blending down here at the bottom, your text message. Ash Design is curious about tall, thin wall parts without chattering. Oh man, you guys are getting me going today. I think I just got another email, and I want to make sure that it's not somebody asking questions. Awesome. There we go. So again, Big thing here is we've done this before. We've talked about the O-ring grooves inside of Fusion. Now, I think I am correct in my assumptions of what Travis is trying to do, where he would want to do something like a 3D contour down here at the bottom of the part, right? So, of course, I have to give this a tool. I can tell you right now, I don't have anything in my machine. So I'm going to go with a T-slot cutter here. And there it is. And then that cutter may have a corner radius, hopefully. So, and with that, let's give it like a 60 thou radius. And now we can use that for blending down at the bottom, right? So I am going to go in the world of 3D contouring, I'm not going to do a silhouette of my part, of course. I don't want to do the whole part. Now, I would recommend to somebody that's new to this is it's actually much easier to do things in Fusion if you hit OK first and then come back and change what you have. As you guys can see, the toolpath is basically doing what I want it to do right off the rip here. And it's actually blending down here at the bottom. The only problem is it's starting all the way from the top of my part. So if you really wanted to get away with something like this quickly, I could easily go to my heights tab because, as I always say, if you pay attention to the blue lines and use a system of filtering, for example, geometry is X and Y, and then heights is your Z height, we could actually say, I want a top height from here, and then we want to move down towards the bottom of our part. So Travis, I assume, with the exception of my stock here, let's get my stock out of the way. This looking pretty good for you to be able to go in and blend the bottom of your part. In the meantime, Ash, I'm going to go ahead and possibly model something up for you on a thin part like you're asking. Go ahead and draw a new part here. And I am actually going to cheat this one, I think, guys. I'm going to go ahead and just throw a rectangle, second rectangle. Give it some dimensions so that I don't look like a fool when this thing is monstrous. And we're going to go, 5 works. And let's extrude. I'm going to go ahead and just give this a nice little base. And we'll go ahead and give this a tall, thin wall, right? So your thin wall may be different on your part. Obviously, all that really matters is we're talking about a thin wall and machining down it, right? Just draw it as a T-slot. Draw what as a T-slot, Travis? I built the T-slot tool, man. So the problem with why it wouldn't let you cut the radius, and I see this a lot, is you have probably gone in, and let's do this. I'm going to do a brand new toolpath so you guys can see. So I'm going to go in and do 3D contour. Now, a lot of people want to come in here where machining boundary is and select stuff. So if I select lower edge and upper edge here, right? Now, when I hit OK, I'm going to get this error, and this error is going to tell you empty toolpath, nothing to link. Well, the problem by default here could be is it's thinking to keep your tool on center of this boundary. So with tool on center, that T-slot cutter is so big, it can't be on center and machine in that boundary. So I would start by go ahead and allow my tool to go outside of boundary and see what I can get second time through. Second time through, I actually got the same results as the first time through. So there's a few options you have. We could go ahead and turn on something like contact point boundary. Contact point boundary, let's see what we get. Still the same results, of course. So then again, just like you guys saw me do the first time, go ahead and filter this down based on a Z height. And from there, that's where you can get that. Awesome. Other questions outside of that? Let's go ahead and jump over to where we were talking about doing something like a very thin wall part, right? So the question is how can I machine a thin walled part and avoid things like chatter? Well, there's a lot of ways you could do it, but on a part as simple as this, your system might need to do what I like to say is like a layer cake, right? Like we need to do it section by section, right? So if I go into manufacture, create my setup as always, guys. And now I am just going to slowly work my way down, and I'm going to do kind of like a rinse and repeat, right? So as you're going to see me do, again, this is a really easy profile, but if I was to do adaptive clearing, go use good old 1/2 inch end mill, And then what I'm going to do is I'm going to start with, instead of lowest of selected, I would change mine to highest of selected, leave it at model top, and then maybe only go down minus 0.5 of an inch, right? So what that is going to do is basically knock out that first section so that I can now come back and machine around this a second time. So again, I'm going to use a derive here because I can jump into my next 3D toolpath. Maybe that's 3D contour. Again, we swap out our tool. Should have a radius end mill. Beautiful. And now with that radius end mill, again, because I derived this out, it's automatically setting my Z height. And then from that, I would say whatever your step down is, obviously what I'm going for is leaving material to keep rigidity as I move down this part, right? So again, this is my first layer. I may put this in a folder if I'm being particular. We'll go ahead and say first 0.5. Drop these two in there. And now I can duplicate what I've got here, right? So again, we're going to go down and duplicate. Now this would be, the second 0.5. Oh, let's go ahead and get rid of that parentheses at the end. And now I could edit those toolpaths. So again, what I'm going to do is I'm going to now say highest of selected model top is minus 0.5. Highest of selected for my bottom is now minus 1, right? And again, we're going to do that one more time on our contour toolpath. So I'm going to speed this up a little bit for you guys, because we've now machined down from our model top a ½ inch, and we're going to carry that system even further, right? So as you can see, now we're roughing our next layer. We're coming back and we're machining around the outside of the part. Now, this might not look the most efficient to you guys, but as you can see, if I duplicate this a third time, again, this is going to be our third, right? Go ahead, third. And if I do a compare and edit, I can use this to my advantage because, as you know, I have a top height, right? Is now minus 1. And then my bottom is now minus 1.5, right? But as you can see, again, I can now quickly generate the third layer, right? So if I wanted to manually do something like this, I know it's kind of a pain, but I'm going to show you guys a couple of tricks to this. But the idea is still the same, is I'm machining down that part section by section. I'm then finishing at that layer before I go a little deeper in my part. So as you can see, this is one way to do it. Now, there is some other ways to do it if you are looking for a little bit more fun, is if we go back to design on this part, and this is when I found out in my days of making molds and stacking up molds, so that if you had like a big awkward shape like a jet ski hull, you were layering up material as you were working. But if we go into surface and I go ahead and create an offset down here, right? I can now take that offset surface and I can pattern that, right? This allows me to create a pattern based on a direction, of course, and I can set my steps now, right? So again, is I am going to go by spacing of 0.5 inch, and then how many I want, of course. So again, you could have did this from the top to the bottom, but now I can use these surfaces as a selected Z height to speed up my process. So again, we go back to manufacture. I'm going to copy, paste, or duplicate, Control D. This will be our fourth layer. And with that fourth layer, again, is now instead of going through the process of a number minus a number, I could just say selection, right? So as you can see, here's my selection for here, which will stay 0. My selection for my next layer. And again, instead of using a offset dimension, I can actually use those layers that I built out with that pattern. So another way we could look at doing something like this, I'm going to go ahead and turn off all these surfaces. Now, when we rough out this part, let's say we wanted to rough it out all in one shot. So I'm going to go in and I'm going to do adaptive clearing. And down here where you see shaft and holder, we're going to go ahead and go back. I want to check this tool real quick because I think I'm going to have to do some magic, some good old Hollywood magic. But if you look at shaft and holder, you have a couple of options. You have what's called pull away. You have automatically detect tool length, and then you have just plain old fail, right? So if I was to use pull away here, I now can clearance based on the shaft and the holder. And what this will do when we're trying to rough this part out is it is actually going to back itself away from this wall as we machine down roughing it out. Again, it would give us kind of more of a pyramid or a pointed shape. That way, if I was to come back in and do some other things, as you guys can see, as it's now backed away, it would give me stability as I ran down this part and tried to finish this up. Now, another way we could look at doing this, again, I apologize, Ash, I see you out there. There we go. Another way we could take approaches at this is when we're finishing something like this, is instead of using something like contour, you could also use something like ramp, right? So again, if I used ramp, go ahead and swap my tool back to my radius tool. The difference between contour and ramp is pretty straightforward. We are now going to go down in Z, again, based on a step down, instead of just going X, Y, and being a fixed situation. So as you can see here, is I actually enter my part up top. And if you pay attention to that very first blue line, we're going to run all the way down. And as again, we're going down in 40 thou increments, and we're basically 3D'ing down this part. So if I traditionally rough this out and left like 30 on the walls, and that's more than stable enough, I could come back with ramp. And then as I work my way down, we should be able to prevent quite a bit of deflection, right? Or chatter in that. So hopefully, Ash, that answers your question. Anybody else have any questions outside of that? Anybody looking forward to next week like I am? I am going to be in Las Vegas pretty much all of next week because I will be at SHOT Show. So if you guys want to see me, meet me in person. I think I'm going to be there till Thursday before I fly back out and head this way. Again, anybody have any questions? Any questions at all in chat? Sorry, I got another text message from another customer. Trying to do the math in my head real quick. They're doing something with the tap. So you guys are going to see me do some math here real quick. We got a 32 threads per inch. 1 divided by 32.03 times 500. 15.625. That looks right. So that thread pitch 3125. Cool. Other questions? Oh, TC Alpha. Troy, what's going up? How to clean up that crappy toolpath. Troy, you gotta send me the part for that geodesic toolpath. I don't think you ever sent me a part. I can go back and look. Let me see. Did you send me the part itself? No, you just sent me a screenshot. You never sent me that part. Go ahead and send me the part on that ticket that you have open, and I'm more than happy to pop it in here and take a look. How's everybody else's week going? Pretty easy week? Anybody swamped? Hopefully, if you're swamped, you're still here watching. So this next week is SHOT Show. It's the biggest gun show in North America. Actually, I think it's probably the biggest gun show in the United States. It's also, so I'm told, not open to the public. So some people do know about it. Some people don't. It's kind of more of that business to business, what's coming out next year for vendors type scenario. A lot of guys with FFLs will be there looking for new customers. Travis is getting a new machine. Travis, what are you guys getting? Go ahead and double check. Troy, you're sending that part in, hopefully. I don't think I have a copy of that part anyway. And if anybody is saying anything in chat, guys, sorry. I'm jumped over to the other screen. Working on it now. Awesome. Ash, looks like we got Ash going on. Gonna free up some bigger machines. There we go. Can you make a step file as a form tool? So technically, yes. Ads Camper, do you have the file you can send to me? I could also generically show you guys how to do it without needing an actual step file. So, guys, what he's asking from a form tool is actually in the CAM environment. And there's two things you're going to need. You're going to need a basic sketched profile of what you're looking for, to be able to build that out. And then you need to know the offset point for when you create the tool path from that tool. So what he's asking is if he had a step file of a form tool, changed my name to Sketching Phil. So what I'm going to do is I'm going to very quickly build a terrible looking form. Give me a sec here. And we're going to go ahead and throw some dimensions at this. And we're going to center line this. Life easy. And let's say it's a 1-inch diameter. And now we've broke our model. So let's put in together. 1 inch. Oh, let's go with like a 1/2 inch shank, right? Probably does not need to be as tall as we have it sit. Pull this down. I think you guys kind of get the point of this form, right? Kind of like we're going to do like a router would, right? So with that, I have my profile and everything for my form tool. So if I jump over to manufacture, back that up because the question was about step files. So if I brought in a step file of a custom profile tool, right? As you guys can see, it would look something like this. So now I can't directly convert the step file right over, but what I can do is I can go in and I could actually cut this model and use some features from that, right? So what I'm going to do is I am actually going to say, I'd like to split this body. And now my tool in this case, I do luck out because I drew this lovely profile. My origin is sitting right on center line. And now that I have two halves, I can go through and use one of those halves to create my profile on my geometry. So I'm going to sketch on that face. It's going to auto project the geometry around the outside. And I'm going to throw a line down center, midpoint to midpoint. Because what I'm looking for is to break this into basically two halves, right? Because that's what Fusion's going to want to know in the form tool is what is the profile of the tool? Where is the axis of spinning around center, right? So again, we go now to manufacture. And I'm going to go ahead and turn off the model here so you guys can see. And then I'm either going to get lucky or I'm going to mess something up along the way. So we're going to go ahead and what is my profile? And what you're noticing right now is it's giving me the profile all the way around my part, which was something I thought was going to happen anyways. So I need to break or split the upper half and the lower half, right? So let's go back to design real quick. We're going to go into that sketch. And in that sketch, we do have something called a trim/break tool. So we're going to go ahead and go with the break tool. Now, what you're going to notice is I can't actually break this top line that is a projected line. So another thing I can do, though, is just draw that line on one half, right? So again, sometimes you can cheat the system. We're going to see if this works out quite well for me. As you can imagine, I feel like it's once every 6 months I get this question about a form tool. Now, as you can see, because I did extend that line over, it is reconnecting it to the projected profile. Again, giving me a half profile of that tool. So now my axis for my tool is here. And then my compensation point, this one, I feel like no matter what you do is always going to be wrong. But we could either do bottom center or we could do an outside corner of that compensation. So bottom center is commonly more used for like your engraving tools and things of that nature. Now, when you're doing something that's involving kind of an end mill approach or a custom ground ply cutter, is you usually want to go the outermost point wherever you're going to touch off and reference. I like to tell people when I select the edges I want to machine with, That's the point that I want to use, right? So if I hit OK now, nothing happened. Very common. Be a little crazy here, but the thing is if you look at your tool library, it has now created that form mill profile, and then what you're seeing here is that red point is the reference point of how that tool is going to work, right? So if I wanted to now use that tool, if I have a part I can put this on, sure, we'll do it on here. 2D contour around the top. Go grab that form tool. You need to jump across parts here real quick. There's my form tool. And let's just go ahead and say we're going to go, a 1/2 inch down the part, right? You do need speeds and feeds, of course. So Fusion at its greatest time is always telling me that you need to plug in some speed rates. Might have to go back to the top level, of course, and give this more info. So I'm going to plug in some generic stuff. There we go. 50 inches per minute. Sounds pretty good to me. And now you can see, like I said, this is our reference point, which is going to follow our profile that we selected, right? So again, now that we simulate this, you'll see it comes in and now it rides around that edge of our part, following that lower point of that profile. Again, if I was cutting crown molding or something like that, you could see how that profile could be much more advantage for you. So hopefully that helps you out. Like I said, is the quick way to usually get away if you're using a step model is you're going to use that split body. You're going to split it in 2 halves, right? And then you can create that sketch. And again, make sure that you get a profile chain that goes all the way around, or else you're probably going to be kicking yourself. Let's go ahead and see if TC Alpha went ahead and sent us a file yet, or if he's still making us wait. Oh, there it is. So that, let's see. Travis, what'd you send me? Got a screenshot of a part. Oh, this is a different Travis, I think. Maybe, maybe not. Oh, Troy, I'm sorry. Troy, I don't see the part yet. But I was also talking to the other Travis that's in here that always is hassling me. Troy, did you send over? Oh, there we go. Let's get this downloaded and then put in. Page is not working. Download. Did I lose you guys? Are you guys all still out there? I, for some reason, not download Travis's file. Or Troy's file, I should. There it goes. Finally. All right. It is now snowing. Actually snowing outside my window. Oh, let's upload. Oh, that was you? Yeah, Travis, Travis sent me a photo of engraving, and it's the wrong direction. It's his, access to actually go the other direction. And you guys are just getting me everywhere. Let's see here. Who else is texting me now? Alrighty, there we go. Somebody's asking me a bunch of tapping questions. Definitely, we can cover that here in a sec, Deep Thinker. We're going to get this part opened up for Troy. Troy. 5 inches of snow in Dallas. It's probably already gone. I will say this, guys, if you didn't know, I went down to Lincoln, Nebraska this week, and I will say that it almost feels colder there than it does here, but it's because there's no snow on the ground. So, I look outside right now, and I don't know if you guys would be able to see it. If I can get turned here. I don't, yeah, it's not going to zoom out my window. But do you see how white that is out my window? It pretty much is the same outside right now. So we're going to go ahead and check this out. I don't think I have the right file open, Troy. We're going to go back. You have a different, let's see here. Troy, what file is it that has your toolpaths in it? Oh, there we go. I think we found it. And you were complaining about a geodesic toolpath, right? There we go. It looked like it was that one per your screenshot. Like it was that one, right? Cool. So as you guys can see, Troy does things with intakes for LS engines and all of that. And the first couple of things I would point out in Troy's case is, although the geodesic toolpath is kind of doing what he wants it to do, it might not actually be the best toolpath for this right here, right? So no offense, I am going to go in and I'm going to attempt something with multi-axis finishing. Now, what this would allow me to do at the end of the day is, instead of doing floors, I'm going to do walls. And yes, Travis, you possibly very much could use flow. Now, I have my wall surfaces here. I'm going to go ahead and select these around. Now, I can never remember if this toolpath absolutely needs a floor or not. We're going to go ahead and try to send this without it. We're also going to blend top and bottom. I can create my curve to guide this, whether it be automatic, which means it's going to define it between the two, or as you're seeing, you have ceiling versus floor, and I could do a selected edge. So if I wanted to blend everything coming off this top edge here, and then we have our passes tab, 1, 2, 5. What tool do we have in here? We have a lot of tools in here. I think he was using a ball end mill with a mile-long reach nonetheless, right? But let's see what we get by default. Now, I am going to do a couple of things, as you guys may have seen in my videos. I'm going to turn my actual tolerance up. This means it's going to calculate faster. If I was going to run this at the machine, I could put that tolerance to a much tighter tolerance. Now, I am going to leave all of my settings as is right now to see what I get first time through. So as you can see, yours truly, of course, did not pick a floor, and it told me I needed a floor. So let's give it this floor down here at the bottom. So as you're seeing, we're going to go ahead and let this toolpath possibly do something today. And we got a guide curves are too far away from the surface. Beautiful. So let's ditch our guide curves altogether and send it one more time. So even the best of us over here, we get a little too crazy with our mouse clicks first time through. As we've always told you guys, it's more important to get blue lines on a part than it is to actually get a perfect toolpath, in my opinion, first time through. Because as you can see, and I think this is probably blowing Troy's mind over there right now, that I was able to go in and do so much with this toolpath. Now, keep in mind, I just used what he provided. Here is the floor. That tool is obviously respecting the floor at the bottom of the part, right? So he would need a floor that's deeper to go even deeper in there and blend that through. So in this case, the reason why, Troy, I'm not trying to tell you you're wrong. I made a video a while ago about using geodesic for some fun stuff, but geodesic really tends to be more of a floor finishing strategy. And the way you can tell stuff like that is because it's giving you a scallop and blend here. And then if we look at our passes tab, it's asking you a step over, right? It says, what do you want to step over? It doesn't say step down. Usually that's a good giveaway that it's more of a floor strategy than a wall strategy. Now, before the haters get out there in the comments, yes, I know multi-axis finishing now has the ability to do both walls and floors if I can find the button, right? So you could either do wall and floor, or wall or floor. But again, I can force this to strictly do one or the other. So as you can see, very minimal effort going into this to get a much better toolpath, in my opinion. Now, one thing that's cool, I'm going to take a complete shot from the hip here, is if this pocket was the same as this pocket over here, I see him programming things twice. I'm not a 2x programmer, right? I would actually go up here, and again, this only works if things are identical, is I could pattern his first toolpath using a duplicate pattern. Now, the secret to duplicate pattern is you have to have the same reference point. Again, this is the importance of A and B being able to take one toolpath. Again, these have to be identical. I can't make this up, guys. Is they have to be identical, because if these were like two ports that were V-tapered into a smaller kind of area, this wouldn't work, right? Because you would kind of have a left hand and a right hand scenario. But as you can see here, I do believe most things on a Chevy are all put on the same spacing. But you can see, instead of making two toolpaths, I could use that duplicate pattern to carry over doing both of those. Now, this leads me into a really good thing, because this just reminded me of something somebody had asked earlier in the week. I am going to simulate this and hope my computer doesn't explode. But as you're going to see, direction is not supported. Okay. Let's go ahead and see what is going on with his Mach 770. So as I think we're talking, I really do see the fact that I know why he was using geodesic. He only has a 4th axis. He doesn't have a 5 axis. So I got to back myself up here real quick. But what I wanted to show you guys is somebody had this dilemma. They were using the ability, yeah, poor me. Hey, you have a 4-axis CNC mill in your garage. So, I mean, I don't know how many of us can say that. But the problem is my customer was getting Z over travels in simulation. So when you pay attention to your linking, guys, you got to make sure that your linking isn't exceeding your Z height in your machine. And it was a very simple fix once he saw the problem, right? So again, I didn't want to use automatic clearance. Now, I want to make a video later about this for you all, and this is kind of something neat. So I could say cylinder clearance based on a direction, right? So in his case, he does have setup X, and then I can go off an origin or a selected point. Again, what's neat about creating that cylinder is, as you're going to see here, is I could type in a diameter, and then we could say something like 4 inches. As you're seeing, I'm setting a custom clearance based on some settings. I am going to do a video on Workflow Wednesday for something like this. But as you guys can see, is going in after. I can't stress this enough. It doesn't matter the toolpath in Fusion. Click what you want to do, hit OK, and try to get some blue lines, right, guys? But as you can see, I can go back and start to modify my blue lines or change how those things are interacting. So again, that clearance height can be your best friend. Now, I did see some really, really good questions. John, great to see you out there. Is what if we went about this a little differently, right? He has only a 4th axis option on his machine. He does not have 5 axis. So there's several different toolpaths that might work out quite well for him. Now, I would be curious, maybe a rotary contour would work. I don't think it's going to, but let's go back and look at a few other things. So I'm going to go back and we're going to take the example or the suggestion we saw, which is the flow toolpath. Now, a flow toolpath is surface driven. So again, we're going to give this just a couple of simple surfaces. I am going to leave it as 3-axis because I am going to start out with my tool orientation, right? So again, we're working with a 4-axis. I'm going to go ahead and kick Z this way. Now, I am going to have to tilt it a little bit more because of undercutting and getting down inside that pocket. So again, we have our flow toolpath. I'm going to go ahead and step over 125. Again, this is where I think a lot of people get a little confused. It's asking for a step over, not a step down. So again, a flow toolpath tends to fall into that category more of being a surface floor finishing, not surface walls, right? However, you're seeing we are running up and down. Another thing that we are happening, and this is something I think a lot of people don't realize, flow, when you pick surfaces, it tries to retain what that toolpath is going to do between the edges of the surface, right? As you guys can see, is I fan across one way, and then I do something completely different in a different area. So let's go look at a few other options. Well, I am going to go for, if somebody can, you know what? I'm going to pause real quick. So I am going to actually ask all of you what toolpath I should use, because I think some of you out there have a pretty good idea of what might work for this. And I also completely firing from the hip on this. Deburr is not going to work. I mean, you could set your deburr to like 1,000,000 step overs, I think. But there is other toolpaths. And the reason why I'm saying that is, in particular, if you look at the description of kind of the geodesic, again, it's for floors that are uneven, right? Same with looking at our flow strategy. If you look, it's kind of doing the top of this mouse, right? Again, more of a floor strategy. Blend is a very good strategy from time to time. Now, again, there's a lot of different toolpaths here that we can use. So I'm going to go ahead and give you guys a couple seconds to think about this. What toolpath do you think would work for a 4-axis only on something like this port inside of this actual part, right? So we'll give you guys a few more minutes. Probably not a few more minutes. I'm going to see who's texting me a bunch. I'm also seeing I'm getting some emails on the other side. Getting tapping questions right now. Pretty interesting. Here's a question for you guys if you guys aren't going to answer that question. How far would you stay off the bottom of a blind hole with an up flute tap? When tapping a blind hole, you pre-drilled it. How far would you tap down with an up flute tap? Now, some of you are going to give me yeah, I like 85%. 85% looks pretty good. I was going to say, some of you guys were going to give me the old engineering, like there's a certain math equation, blah, blah, blah. And then I'm going to tell you it's in aluminum and I would have rolled for it. No, I like it. Somebody says ramp, spiral. We can go ahead and go for it. John, pretty good. Yep. I mean, really depends on if the chips are getting cleared out. In this case, customer has through coolant spindle. There's not going to be any chips in there when he's done drilling that hole. So let's go for ramp. I like ramp. So let's go ahead and go for the ramp toolpath. Now, again, the real key factor here is we need a toolpath, as I said, because we need to confine this to a 4-axis only type of situation, right? However, those of you that know me, I always like to start as simple as possible. So again, we're going to go ahead and set our z-axis to our angle. We're going to go in and define our step down. So again, we're seeing step down. It's very beneficial. And we're going to go ahead and up our tolerance so we get a toolpath calculation. Now, I completely screwed that up. And as you can see, we've machined the entire part. But something that's kind of cool here is we are machining down into that cavity, right? So as you can see, we've almost got what we want. We've just got a little bit too much of what we wanted. Let's go back and make a couple of changes. So I'm going to go ahead and go to my multi-axis tab. As you can see, we could switch over to 4th axis, but let's limit where that tool is actually going to go. So I'm going to give this a selection boundary. Now I am going to maximize my window of view here and then have my tool hopefully stay with inside of that area. So let's say tool center on boundary, and small changes make big differences on parts like this. As you guys can see, I've now refined down even farther inside of that area. However, I'm going to go ahead and do a section view here for you guys. And what we want to look at this part from the side is my tool path. Again, we're locked in strictly 3-axis machining. So we're going straight down inside of that part. So we're not quite fanning out and getting all fancy yet. I see Troy out there. Troy's saying G's in the chat. But as you can see, this is where I'm like, you know what? I have my tool path in X, Y. I'm now going down in Z. I'm just not going out the way I want. So let's go back to ramp. We're going to go to multi-axis, and we're going to hit this with the 4-axis, right? So, of course, we have to tell it, what do we want in the 4th axis? I want to use setup X, and that is basically the only thing I'm going to start with, and we're going to see what we get. So, again, we hit OK, and as we're going to see that toolpath start to come out. Now, something did happen here, and I've made videos about this because you guys always ask the question, and I use the best rule of thumb. If you and two other people ask me the same question, I like to make video content on it so that you all learn, and then I don't have to answer that question the fourth time, right? So the problem we're having is our tool is still pointing to the rotary axis, right? And what's funny is that blue line with the red right here is our rotary axis. So fourth axis is working. The problem being is it is trying to point itself directly at this edge right here, this blue line that we see. So this is where I made that video about to curve, to point, from point. We need to decide what is going to work best for our situation here. Now, I am going to go for to curve to start, and I don't think it's going to give me what I want. But what I'm going to pick is the curve at the bottom of my actual part. And let's see what we get for a toolpath. Now, I did see a really interesting video out there on Facebook from not a competitor, but somebody that does this full time. They were doing a V6 head. I think it was for a Nissan engine. And he actually used from curve. And I think that's what we're going to go for here, right? So again, is the tool is trying to maintain pointing at that curve, but we're still not getting down inside of that pocket as much as we should. So let's go ahead and jump from manufacturer back to design because we need to create our curve, of course. So what I'm going to do is I'm going to create a sketch. Actually, we're going to create a plane because we need this curve to back up just a little bit. Now we can create our sketch. And then what I'm going to do is I'm going to project a few things here. So let's go ahead and project this edge and this edge. Now what that is going to give me, it's going to be a little tricky, I think, for some of you guys to see. Let's get our grid out of the way. Should be able to turn off our grid, right? Of course not. Grid lock grid, visuals. We don't want to see the grid, but I think we'll be okay. Let's hit OK. Can't turn off the grid. That's funny. So as you guys can actually, no, you can. Where is it? My brain is not working. Construction, projected, constraints, dimension points, profile, sketch grid. There it is. So as you can see, the reason why I brought that off a little bit is so that I can see the lines, right? And I made those lines because in theory, I need a straight line across here. So what I'm going to do is I'm actually going to create a line that is way too big. And then what I'm going to do with that line is I am going to actually constrain it with a perpendicular. Now, you don't have to do this. And actually, what would be better than that is a parallel, because we want to stay parallel to our jigs and fixtures. Again, I'm not going to get too deep in this, but I think you guys are starting to see, again, we could project. We know this is a straight edge on this part. Now, I would like for this to be perpendicular off of this. Now we're getting that, you know, again, constraint doesn't work, but the idea is if this line is perpendicular to everything, we should be safe. Now, one thing to keep in mind, we could also create this line as an angle. We did actually constrain perpendicular to here, which I'm pretty happy with. So let's go back. As you guys are going to see, we're now going to go back into our toolpath. And now the idea is in a from curve situation, we're going to say from curve, is I want to maintain the tool line going through that edge, right? So again, as we're going to go in, I only want this one sketch segment. And now the tool is going to constantly point down through that, or at least it should. So we got no passes to link again. Let's see what's going on. My Z-axis is completely pointed the wrong way because I picked that edge early. So let's go ahead and fix that. And again, now what you're seeing, and this looks weird, keep in mind my line is so close and it's trying to machine this upper area. But as it works its way down, that's what we're starting to see, right? So again, as if we simulate this, you're probably going to get, yep, TCP enabled, which is not supported. We need to turn that off. So we're going to go for a standard simulation here. So this is where the value comes from curve. Now, I did this intentionally, keeping it very far down and close to my part. But if we start to simulate this again, boom, you can see we are constantly maintaining the center line of that tool, right? And this is my blue line, is going to go straight through that line. So obviously we need to move the line up, right? But as you're going to see here is it's going to keep tilting itself, always keeping the center line of that tool as it bounces back and forth. So what we're going to do is we're going to speed this up a little bit. And as we work our way further and further down, you're going to notice that tool gets steeper and steeper as it can reach our pocket, right? So again, that ability to use that through curve is allowing me to actually keep the center line of that tool always pointed through that curve as it works down and machine everything out. Now, something I am recognizing is on this specific profile, we're going to ignore the tilting real quick, is odds are we're probably not able to get underneath here, because if you remember the projection of our boundary, right? So we picked this outermost edge right here, is odds are it's not allowing it to get underneath here, or it's being limited by undercutting, right? So this is where we may need to, once again, do a few little things to this part to get a little better result. So what I personally like to do at this time is I would go in, and we did a selected boundary, but I'm actually going to say no selected boundary. We're just going to go for the good old-fashioned bounding box, and we're going to see what we get. Because again, we need to get those blue lines going up underneath that part. Now, this might be the limitation of what this actual toolpath is capable of. And I think that is what we're seeing, because this toolpath does not have capabilities of undercutting inside of that area, right? Now, if I was to tilt, again, we're going to do a tilt here because we're still using tool orientation. If I start to tilt back more, again, might be hard to see for a lot of you. Let's get some stuff out of the way here and clean up my workspace, since you guys like to hassle me about that. Where is, yep, so we got another origin hiding somewhere around here. Where is it? And then what I'm going to do is I'm actually going to hit F7, which turns off that toolpath. So again, is what I'm doing is I'm tilting my Z back more to see if I can get up under there, right? So again, we're going to see if that changes the angle of that blue line. Does it give me more reach inside my part? What is going to be limited now with what we're doing? I do need to hit F7. Again, what we're seeing is we are now getting up underneath there. Obviously, we're getting limited as well down here in this area. But I think you all are really starting to see that, yes, something like ramp, and for visual purposes, let's get links out of the way, is we can do quite a bit with ramp. Ignore a lot of what's going on the top, but ramp does get down in there quite well. Again, it's still being defined by my tool orientation down into that pocket, but I could also move this line up and out. So I did see another question about spiral. I would be curious, but I think, this is me, when I look at spiral, it's another strategy meant for more of the floors or the shallows, right? So hint about what I'm asking is there is another toolpath outside of there. And I do have to say, we have 21 people in here staring at how we're porting out something with Fusion. So keep in mind, for those of you that are new in here, by all means, we are on a mission to port out this actual intake part. And with that, we are only limited to 4th axis machining. So those of you scratching your head, we did program this part already once with a full 5-axis situation, and it turned out really, really well. But we're now looking for a solution with a 4th axis only. So I'm going to give you guys a few seconds before I dive into it. And I'm surprised nobody recommended it. But there is this fancy toolpath called steep and shallow. Now, why I like steep and shallow is it's a little misleading, because you're like, Phil, you've been saying this whole time, like, toolpaths for the floors, right? Well, it's still a toolpath with 4th axis. However, we're going to go ahead and hit tool orientation again, of course, right? But when I go into my heights and my passes area, I can force steep only, right? So just like multi-axis contouring, or multi-axis finishing, I should say, upon going steep only, I get a secret here called machine undercuts, right? So this is where some stuff starts to happen, where if you're somebody that was asking about a lollipop, that lollipop cutter will actually creep under there as well. So again, we always like to get the blue lines on our part, turn our tolerance up so you guys don't stand here for 20 minutes watching my computer burn up energy. So we're going to go 40 thou step downs, same tool, still only 3-axis with orientation. and then steep only with machine undercuts, and let's see what we get. So again, I'm expecting this toolpath to go all the way around the outside of the part, of course, but what we're really concerned with is how can we get that tool down in there and be able to machine or port out that cylinder with 4th axis only. So again, this is auto trimming it as it goes in right now because it is only 3-axis machining, but I would say for a first go around, that looks pretty good, right? So let's go ahead and up the ante. Let's go ahead and kick on 4-axis now. And what you're going to see is, again, we have to redefine setup X. Of course, it's 2 rotary axis. We could also do a lead and lean here. If I remember correctly, I don't think we had lead and lean when we were talking about ramp, but we could always go back. What lead and lean allows you to do is to actually set that tool at an angle versus doing through contour. But we're going to let that calculate. Let's check ramp one more time why that calculates. We do not have lead and lean here inside of ramp. So that was one of the things that I did know that we were going to get inside of steep and shallow. So I am going to let this go. As you guys are seeing, it's now getting much more messier and messier. But we are starting to work our way down inside that part. Now let's look at our containment here. Again, our geometry is currently none, but we do have contact only. Maybe we turn off contact and see what we get. They are only available in the machining extension path. That is correct 100%. So again, let's go ahead and try something else. So we have lead and lean. We're not leaning any right now. So let's give this about a 15-degree lean and see if that helps our tool. I would have to say, though, if you're out there porting, and doing things with a 4th axis, I don't think the machining extension is a huge reach at the end of the day, considering what parts like this are going to go for or what you're probably charging a customer. Now, I know a lot of people that actually pass off that cost of the machining extension to their customer as if it was specialty tooling needed for making this part, right? You order that tap that you only use a couple of times, and from there you can get that result, right? So let's play around with this a little more. If anybody has any questions outside of this, why I continue to try to get this toolpath to work, feel free to put them in the chat at any time. Again, let's start with a 2 curve and see if that helps us. As always, we appreciate each and every one of you. You guys thoroughly enjoy this content and enjoy watching me blab my mouth for what is now an hour and a half. We are an hour and a half into this. Every Friday, it seems. Yeah, we've been on a pretty good streak. And good news, I will be around next Friday as well. So again, just trying to see what I can come up with to get that toolpath down inside that pocket. Again, we did have a talk with Troy about possibly doing this the opposite way as well. So again, let's go in. We're going to go ahead and set, instead of to curve, let's try from curve and see what happens. Any other questions outside of that? Anything else somebody else wanted to see? If not, I do need to go get water. My throat's getting a little scratchy here. If only you had a 5th axis. Yeah, we could all say that same thing. I'll let this calculate before I go ahead and pop off for a break. Give her a few more seconds. Yep, it doesn't like that from curve. So again, let's go ahead and see what we can do here. So let's pull. We're going to leave tool orientation off. Oh, we had too many edges in there. That's why. Little late, but you're here. Benjamin, great to see you. So the issue, I just had that last toolpath. It actually included this curve with all of the bottom curves, and it was in a panic. It didn't like it. Let's see what we get. So, hey, look at that. I'm not a complete liar about anything and everything, but as you guys are seeing, we are now getting a 4-axis toolpath that goes in the port, also fans out all the way around the port. Now, again, we're coming down to the bottom floor. We can, of course, extend down further. And we could also clean up this top quite a bit, as you guys can see. But we are getting to where we need to be. Again, that steep and shallow, as somebody pointed out, it is a part of the machining extension. The reason why you would like it is because you have 4th axis like this. But I can also go in and do something like this, which is called trim toolpath. And we could very easily say, keep the tool only inside that lovely little rectangle I just drew. And now, with a trim toolpath, I'm only machining a small section of my part. So that trim toolpath, that delete passes, becomes a very, very good tool to go through. Bottoms are removable and taken out of the fixture. Yep. So as you 100%. So that's actually not part of the machining, as he's saying. So again, is we can go through and we could remove. Let's go to it. And what's happening is I love stuff like this, right? So he has a fixture here. And in his fixture, it might be a little hard to see. He has this piece of his fixture selected. And a combination of this piece here selected and this 200 clearance, and I say 200 clearance, is causing this toolpath to not be able to actually machine all the way down inside. So as he said, these pieces right here are able to be taken out. So we could go in. I'm going to reselect your fixture here real quick. We're just going to give it a couple of pieces. And I'm now ignoring this bottom piece here, right? And now if we regenerate that toolpath, you should be able to machine even further down inside there. Give it a quick second. In the meantime, I'm also going to try to figure out where that body is. And that is this piece right here. So what he's thinking is he's actually going to leave that open when he's machining. As you can see, it's now starting to creep down further, of course. We are still running into more than likely clearances based on some of those settings at our jig and fixture level. The nice thing is, though, is if we go back into this toolpath, we look at our geometry tab, you can override at the individual part level. So you guys can see right now it's still thinking 200, but if I say minus 0.150, and now change that to 46. Again, over here, we're going to say minus 0.150, and now we're down to a clearance of my jig by 46. Travis, you're 100% right. No water, maybe a beer? Definitely. If you guys, I do have to put that out there. I mean, I got to hit you guys with the sales pitch for maintaining my drinking. So again, I want to show you here. Again, we reduced our fixture clearance at only that toolpath. Now, you could have did that at the top level, of course, in your setup, but we've now gotten it down to that 46 thou. Again, our toolpath is starting to creep further and further down into that part profile to be able to machine it. Should I hit you guys with the sales pitch and then go grab water? So you guys can support this channel, this content, this person in a lot of ways. And you could do so at the freest level possible, which is subscribing to our channel, sharing our content with people that you know could enjoy this as well as use it for help. And you can hit that like button down below. Now, if you want to move it up a tier, as somebody has already pointed, you are more than welcome to buy me a beer using the link down below. You can also put super chats inside of chat now for anybody outside of North America. I know a lot of you guys over in Europe like to buy me beers as well as Australia. I will still drink those. I might even consider buying Australian beers. But with that being said, you can also buy Fusion directly from us. Now, Fusion 360 is currently 30% off for all new licenses, and we can help get you a quote by the end of the month to get you set up. We also offer support packages as well. I couldn't remember the name of it, and Foster's. Yes, Foster's. That's what it was, the Australian beer. So I'm going to go ahead and be back in a second. I'm going to go grab some water because my throat is starting to get a little blown out. All right, we're back. I had to go get a mason jar full of cold water. I do see some other recommendations. Let's see here. So Deep Thinker, you draw a line from the inside back wall, far reaching, and from the lower mouth wall, inside front wall. Those two lines meet. Use that as a reference. Yep. So I think what you're referring to is this point and this point, right? Am I correct, Deep Thinker? And go kitty corner between those two? Oh, I'm not sharing, of course. There we go. Also, hilarious joke in chat, whoever put that out there. Oh, wow, there's a timeout button. You guys keep it up, and I'll put you guys in timeout in chat. But, Deep Thinker, is that what you were thinking is going kitty corner from this point to this point? I went ahead, the two purple projected lines. Can't see the other screen. Here and here. Dot. Dot. No. Okay, well, I tried. But the cool thing is, so that you guys can see, is if you noticed, I did that from curve setting, right? Now, you could go from point, but it won't work in a fourth axis. And we did this on the design side of things, and I created that sketch, right? I also could have made that a rectangle, as funny as it is. Now, keep in mind, Fusion is going to maintain the distance shortest to shortest, right? So whether it be a rectangle or a circle, when I'm manufacturing this, it doesn't make me a liar, hopefully, today, is Fusion wants to keep your tool from that line, the wall, in the shortest distance possible, right? So it's not going to ever go from this line here to this back wall, right? It's always going to maintain that from this line, and that makes sense. So again, as you can see, here's my tool path once again. As I stand, I may actually stand corrected as if it almost got better of a tool. Let's simulate this and see what happens. So one thing we did see is there was that lovely error in his machine simulation. Let's fix that about TCP. We're going to go to his kinematics tree. We're going to look at his A-axis, and we are going to turn off TCP. That should, as a whole, fix this so we can simulate it with the full-blown machine now. So let's simulate with machine. And multi-axis finishing. Of course, we just delete that tool path. Not a big deal. Nope. And let's simulate just this with rewind. Hey, there we go. Got to turn rewind on now. Again, we go back into that tool. Let's edit. For those of you that don't know, if you have ever gotten this in the past, you go to multi-axis and you allow a retract and reconfigure. This will trigger a rewind logic. But let's see what we get now. Probably more errors, because that is how this goes towards the end of the day. And in this case, of course, it does go that way, but let's fix his simulation a little bit more here. I think we lost some things when yours truly went in and defined the fixture. We're actually going to add that in. Fixture attachment. Yep. So let's go back here. Back to our setup. What do we miss? Well, let's get our section view out of the way to start with. There we go. Missing the other end, ain't I? Where is it here? There it is. All right. So now we can go selection. This. Leave up to this guy. Beautiful. I assume you probably put this in the opposite direction, but I think we're going to be okay for this. What I would actually need to do is I would actually say pick Z, pick X, flip X. Now attach it back the opposite way, right? So I want to attach based on here. Put that in that lovely little 3-jaw chuck. And there we go. We should have our part on the table now. Simulate with machine. Don't want to simulate everything. And let's see. Exit. Regenerate, of course. And then we could take a look. Don't tell me other way, boss. This is your file. You have to get mad at me because it came through wrong. All right. There we go. Simulate with machine. Requested pose could not be achieved. Steep and shallow. Woo, look at that. So I don't think we're going to get to the point where we're able to simulate that. Actually, let's do this. Let's start with the basics. Going to be moving this plane much higher. We could move our sketch higher and take a look. You probably do have access limits turned on right now too, don't you? Again, we're going to lose some stuff here because, again, that tool can't reach under there. I would need to move this rectangle more to the right to get back inside of there. And let's see if we can simulate it finally with the machine. Hey, there we go. Don't need stock. Get our stock turned off. And we could actually turn those sketches off. And let's see what we get. Again, what you're seeing happen here is we are very steep on everything at the end of the day. And again, based on where I draw that rectangle, the tool is coming from that rectangle for clearance down inside the part. Now, there is a lot of work to be had to this. Tons of stuff we could still do to get it much better, much cleaner, much quicker, right? Still got to clean up the top surface. Yeah, I get it. Also might not want to start. As you're seeing, we're machining these upper walls here. We don't really need to. He's already done that with a flat end mill, right? I get motion sickness. We get too close there. Questions outside of that so far? Thank you, Leon. This is the first time I see you in chat. Leon, you got any questions that you would like to see? Just trying to clean her up just a little bit more. No problem. Anybody else have any other questions? I see quite a few people came and go. Maybe I should check the emails. I see. Looks like somebody sent me an email. Yep. Got to build a machine simulator today for somebody. What about you guys yourself? It's Friday. What's everybody up to? Oh, got some models downloaded for stuff I got to do later. That it? Is that all the questions? No problem, man. You enjoy your weekend too. I already know what you're going to be up to, obviously. You know what's funny is I always love when people like this, they send in something and it's like a Tormach. And in this case, he's building intake runners for an LS engine. And it's like, people ask me, like, what's the best machine? What machine would I buy? And it's like, he is doing it on, I'm not going to say a bad machine, but he's on the low end of the spectrum and he is gaining a fortune off a lower side of the spectrum machine where I've seen fortunes lost on like top of the line machine. That's right. Beautiful. Guys, do you have any other questions? I know I went and grabbed water late today. We're starting to wind down towards the end of all of this. Guys, don't have any other questions? I'll give this a few more minutes here before I go ahead and jump off and finish out my work and hopefully be done before 6 o'clock for one. Check out mail from Tony. Uh-oh. This never goes good. But you sent me a sketch, didn't you? I see. All right, let me go back. You were referring to... I see what you're doing. Yeah. So I assume those blue lines represent the side view from the pocket, right? Okay. Tony sent me a lovely, lovely photo. So what he was showing, and I'm going to try to draw this without doing a ton of extra stuff here. Gonna be able to get away. So when we're going to have to really give... All right. So here's this. We need to turn off some stuff. And he's saying, try to think the best way to do this. Where is my part in here? That is... There we go. We can get rid of those inside. So what is happening is we need to use a project, right? And what I really need to do is going to be create a new plane for my sketches. Actually, let's do this. Let's make this really fancy. You guys are going to learn today. I'm going to do a mid plane in here and here. And what I'm going to do is I'm going to create a sketch on that plane. And then I am going to now project some lines. So what he's thinking is with this line here and roughly this line here, it'll get better here in a minute. Bear with me. Get the model out of the way. Is that putting this line that I drew before basically out in space on a continuation of this line, right? So as you can see, we can run this all the way out. We could also run one from this side all the way out or wherever that flat is and basically set our point of reference to be so that these two technically will reach from this point. Oh, we're going to go ahead and remove that constraint. Like so. And then we know when we're machining this, right? That tool, I'm just using a line to represent it here, guys. That tool can now reach down underneath that part, right? But as you can see, he's not wrong by any means as being able to utilize something like this. And then I can, of course, move that other sketch that we have and place this line lower or place the rectangle lower. Whatever you guys need to do to achieve it, I'm just here to give you an idea of how I look at it. If you guys want to go out and tweak it, be the expert, give me the advice. Love to see it. No upper line. Ash, are you asking about, like on the lathe, you can use a drill and then also use that for turning? Or are you talking about a 90-degree tipped end mill? So you have a 5-axis Mazak. So your 5-axis Mazak, I believe, is by default inside the Fusion 360 library. The 640 MT control. Let me do this. I'm going to jump back to manufacture here. Go check out our post-processor library. And that was a turning Mazak. And then from there, what you're going to notice is there's a lot of different post-processors here. Now, it's going to be a matter of figuring out what post-processor works best for you and your use case. Outside of that, that's okay, no problem. We can also build you a post from scratch. So some of these post-processors may or may not have what you need inside them by default. So again, this capability on this one is strictly turning. You may need a full 5-axis post build because you have a B-axis head, and we're here to help and support you in any way. And you can email me directly, and we can definitely get you set up with something and work. Yep. So I figured as much that was your question. I am going to reuse this part for what is being asked. So as you can see here, we have this terrible drawing that somebody made. And in the event that I had a chamfer back here on this back side, and we're going to have to be a little smart about the math here, so we're going to go 250. But a mill drill, or in this case, basically just a chamfer mill inside of Fusion, is being able to chamfer something that's basically against a wall, right? So in the CAM side of things, if I was to go in and have to make a tool or use a tool for this, is I would make my tool based on a few things, right? So one, I could build this as a chamfer mill tool, right? And with that chamfer mill tool, I of course have a tip diameter. And then you have, of course, everything from there. So if I left tip diameter at 0, again, we would have our 45-degree angle, our diameter, so forth and so on. And then with that, I could use that to my advantage when I'm actually machining, right? So again, I want to go all the way around here. Just want to do this bottom edge. And when that tool comes down now, you're going to see that it would machine right alongside of it. We're rubbing our shoulder right here, but this would give us the profile that we needed, right? Now, something else you could do is if your profile is a little bit different, and again, this is just a whip together scenario, you could always do 2D contour off the top edge. And then if you know the math on it, of course, we could say the chamfer width is 0.25. Again, this would allow you to drop down and away from your part, or I'm actually backwards there. It would still be 0, but we would do a tip offset of 0.2, right? But now, again, I'm getting the same thing, tool move down, out, and away from my part. So, Mads, I hope that helps. We also did a lot about creating a custom tool earlier and using a form tool. You could also sketch up that profile and use it. Cool. No more questions? Mads, I'm sorry. That is, I meant that for Ash. Ash, as you saw earlier with the form tool, you could set it up that way. Awesome. If I don't have any more questions, guys, I appreciate all of you coming out on these Fridays. I will be back again, once again, next Friday. Feel free, subscribe, like, buy me some beers, as always. I live in North Dakota, and it's very cold out today. I think I woke up and we had like 42-mile-an-hour winds outside. So need something to do for my Monday through Thursday before I get prepped for this, of course. With that, it's not what you know, it's who you know. You know Fusion Phil over here at jitcadcam. Feel free to use the support email down below at any time to reach out if you have any questions or any problems. We'll do our best to get back to you as soon as possible. With that, I hope you all have a great and outstanding weekend. Thanks.